Our first success criteria of the chemical reactions unit is knowing how to interpret the different parts of a chemical equation. And in today's video, we're going to be focusing on how to define a chemical reaction, in addition to learning other key vocabulary in order for us to be successful throughout the unit. Before we begin, I'm going to kindly ask you to make sure that you put your name in the upper right-hand corner of your new mini portfolio, and make sure that you put the hour as well. So as we progress in our study of chemistry, there are two key concepts that we must accept not only as fact, but as the basis of all knowledge moving forward. The first is that chemical reactions involve a chemical change. And in that chemical change, a new substance is formed that has different chemical and physical properties from its original material. So in other words, we are making new things or creating new things utilizing chemicals known as reactants. And the second key concept is that chemical reactions involve the breaking and reforming of new chemical bonds as atoms are rearranged to make chemically different substances. Now that we've accepted and believe in our two key concepts, now we're ready to learn important vocabulary that will make us sound more like chemists. The first is a chemical equation, and a chemical equation is a shorthand way to represent a chemical reaction using numbers and symbols. Below is an example of a chemical equation, and we're going to use this model to describe and visualize the next four vocabulary words. And as a friendly reminder, this side is the left side and this side is the right, and that's important for being able to differentiate between reactants and products. Our first vocabulary word is coefficient, and a coefficient is the big or front numbers that one sees in a chemical equation that indicates how many moles there are of each substance. So a mole in chemistry is a counting unit, and that's what our next unit really focuses on. So in our equation, there's two really obvious coefficients. They're the big numbers in the front of Mg on the left side of the equation and MgO on the right side. But in O2, there's technically a coefficient right here. But even though there's not a number there, we assume it to be 1. Our next vocabulary word is subscript. And a subscript is the number written below a chemical symbol that indicates how many atoms there are in just one molecule of each substance. So when given a formula, you are never going to change the subscript. In our model, I see that there's a really obvious subscript here. But even though there's no small numbers written after the rest of these chemical symbols, we can assume that they are 1. So when we have subscripts, I see that when there is no number, I can just assume it to be 1. The next vocabulary word is reactants. And the reactants are the chemicals or the substances that are to the left of the arrow that indicate what substances that are going to take place in the chemical reaction. In other words, it's what we start with. So in our model, everything to the left of the arrow is considered to be a reactant. So I need you to think about this arrow as your dividing line, as between left and right. Our next vocabulary word are products. And these are the substances that are to the right of the arrow that indicate what new substances are formed after the chemical reaction has taken place. In other words, it's what we end with. So going back up to my model, everything on the right-hand side of the arrow are products. That leads us to the law of conservation of mass. So the law of conservation of mass is a key chemistry law that states the mass of all the reactants will equal the mass of all the products. So in a chemical reaction, mass is not going to be created or destroyed. The atoms are just rearranged during a reaction. And there was a part that got cut off. So the number of atoms will be the same before and after the reaction takes place. So in chemistry, mass comes from the atoms, not the molecules. Now we're going to learn how to visualize chemical equations going from these symbols to a picture. So let's flip our note sheet over. So on the reactant side, I know that reactants are everything to the left of the arrow. So these two substances are my reactants, while the products are on the right-hand side of the arrow. So you'll see that this line to divide the reactants and products is right under the arrow, and that was done on purpose. So in 2Mg, the big 2 is my coefficient, and this means I have 2 sets of Mg. But even though there's no number here, that's a 1. So what this tells me is that this is a single atom. So this, albeit very brief, says I have 2 sets of magnesium atoms. So how I would draw that is I would write the symbol and I would just draw a circle on it. And that's what drawing an atom is like. And I'm going to draw it one more time because I have 2 sets. So now that I have my 2 sets of single atoms of magnesium, I can pull this plus sign down, which means and. My next reactant has a 2 here, which means that I have 2 atoms per set. This means that they're bonded together. But because I don't have an explicit number in the front, I can assume that it's 1. So that means I have 1 set of this. So I'm going to draw my 2 atoms of oxygen and the bond between them, but I'm only going to have 1 set of that. Now that I have both of my reactants drawn, I can pull my arrow down. In MgO, there are no numbers, but I can assume there to be 1. So because these 2 symbols are next to each other, that means that they're connected. So I'll have 1 atom of Mg connected to 1 atom of O. But this 2 in the front means I have 2 sets of this. So I'm going to have to draw this one more time. So now that I have my 2 sets of MgO, You might be tempted to pull down this plus sign and write energy. We actually don't need this in our picture because energy is not considered to be matter, so it doesn't matter in our model. Let's do the next one more together. So in looking at 2H2, this little 2 that means that I have 2 atoms in one set, which means that they're bonded. So I'll have 2 atoms of hydrogen connected to each other. But because I have a big 2 in the front, that means I have 2 sets. So I have to draw it one more time. Because I'm done with my 2 sets of 2 hydrogens each, now I can pull down my plus sign. The next reactant is O2. So I have a 2 as a subscript, which means I have 2 atoms per set. But think for a second, if there's no number here, what can we assume it to be? Hopefully you answered internally as 1, which means I only have 1 set. So I'll have 2 atoms of oxygen connected together, but only 1 set of it. Now that I have both of my reactants drawn, I can pull my plus sign down, and I'm going to draw my product. So I see in my product that it's H2O. So I have 2 H's and 1 O, because even though there's no number, it represents a 1, and these are all connected together. And typically, if you only have 1 of something, you put it in the middle of your drawing. So I have 1 O connected to 2 H's. But because there's a 2 in the front, this means that there are 2 sets of them. So I have to draw it all again. So now that my 2 sets of H2O are drawn, I want you to take a few minutes and pause the video and answer the 6 check for understanding questions about this particular reaction. Once you have them complete, you can press play on the video and check your answers. So hopefully you actually paused the video and attempted the questions independently, and now you're just hoping to check your answers. So the reactants in this chemical change are 2H2 and O2. The product in this change is 2 molecules or moles of H2O. Before the reaction indicates we're talking about the reactants, and there are 6 total atoms. There's 1, 2, 3, 4, 5, 6. And after the reaction, there are 1, 2, 3, 4, 5, 6 atoms in the product. So just like on the front side of the sheet, we talked about how mass comes from atoms, so that's what's being conserved or not changing, not the molecules. Because I can have 3 molecules on the left and only 2 molecules on the right because the number of atoms stay the same. The next activity we'll complete is something called the atom for atom exploration, and we will do that next class. If you have any questions, please feel free to message me on Remind or shoot me an email. Thank you so much and have a great day.